Exercise 11A, question number 1. A particle, a body move in a straight line. S is the displacement and T is time. So relationship is given S equal 9T minus T cube. So question number A, part A, then we need to, when T equal 1, we need to find the S. Very easy, we have to simply substitute S equal 9 times 1 minus 1 cube. So 9 minus 1, that is 8 meter. Part B, we want to find, so when S equals 0, we need to find T. So S equal 9T minus T cube, then 0 equal 9T minus T cube, or T cube minus 9T equals 0. So I'll take T out, so this is going to be T square minus 9 equals 0. So I can factorize T minus 3, T plus 3 equals 0. So T equals 0 or T equal 3 or T equal minus 3. Question number 2. A particle P moves on x-axis. Is equal 5T square minus T cube as usual. So we have to find the displacement A when T equal 2 and T equal 3. So when T equal 2, S equal 5 times 2 square minus 2 cube, that is 5 times 4 minus 8. So 20 minus 8, that is 12. When T equal 3, S equal 5 3 square minus 3 cube. So this is 5 times 9 minus 27. So this is 18, 12 meter. Actually, this is part B. So part A, when T equal 2 and T equal 4. So we'll work with when T equal 4. S equal 5 4 square minus 4 cube. So this is going to be 5 times 16 minus 64. So that is 16 meter. So part B is the change in the displacement in the third second. So we want to find 2 to 3 seconds. So we want to find up to 2. The total meters is 12 meters. Up to 3, that is 18 meters. So then this is 18 meters minus 12. So it is 6 meters. So 18 minus 12, 6 meters. Question number 3. A particle moving in a straight line in such that its velocity is v. So particle is moving and the velocity is vms minus 1 and the time t is time with seconds. The relationship is given velocity and the time 3 plus 5t minus t square. T is greater than or equal to 0. Time has to be, it can't be a negative value. The first one, the velocity of the particle when t equal 1. So this is a standard question. So we need to find v when t equal 1. So v equal 3 plus 5 times 1 minus 1 square. So v equal 3 plus 8 minus 1, that is 7. ms minus 1. Part B, the greatest speed of the particle. So now in the given interval, greatest speed of particle and greatest speed of particle in this interval. So we have to be careful when we answer. Greatest speed of particle we can answer easily, but if this is, we have to be careful when the interval is given. We need to investigate about this relationship, I mean in terms of curve. So this is v equal 3 plus 5t minus t square. So v equal minus t square plus 5t plus 3. So I want to find maximum value. This is a quadratic equation. A is less, then we know that it has a maximum. So minus, I will take it out. So t square minus 5t minus 3 equals 0. Then t minus 2.5, I am completing a square. Then minus 3 minus 2.5 square. Then we'll expand this one. So minus t minus 2.5 square. So plus those two together. So this is 9.25. Now we can see that maximum is occur at when t equal 2.5. Okay, 2.5 is within this limit. Let's find where's the v-intercept. So when t equals 0, v equal 3. So I'm expecting this kind of graph, and it has a maximum. So this is 2.5, and this peak is 2.5 and 9.25, and this is, we found out 0, 3 v intercept 0, 3. Then we can tell that this is during 0 to 4 interval. 4 is somewhere. The maximum is 2.5. The other thing is, when t equal 4, do we think curve is here less than 3 or more than 3? So now we have to look at the, so if this is 2.5, 3 and 4 somewhere is here. So because of that, so I'm expecting 4 is going to by the symmetricity, the 4 is somewhere around. Because of that, minimum value is, v value is 3 and maximum is 9.25. But it's come somewhere here, then that is going to be the value. If you are not sure, what shall we do? We can find when t equal 4, then v equal 3 plus 5, 4 minus 4 square. So 3 plus 20 minus 16. So this is positive value. This is going to be 3 plus value. More than 3. It means it should be somewhere here. So part B. So the greatest speed is 9.25 ms minus 1 during this interval. 0 greater than t greater than 4. What will happen if the question is asked what is the maximum speed during this interval 0 greater than 3 greater than 2? Then it is somewhere here. So maximum is going to be, you are going to get at here. Then to find the maximum, then you want to put t equal to. It is not the highest maximum. So it is varying. The high speed is varying according to the interval. If they give 3 to 4, what is the maximum in between 3 greater than t greater than 4? Then maximum speed you will get because it is in the descending. So maximum speed you will get in 3, not 4. So it is depend on the interval. So we have to be careful when we answer. Instead of completing method, completing square method, we can find with the differentiation 3 plus 5t minus t square. So we know it is a maximum. Since a is less than 0, curve has a max, then dv over dt will find this is 5t minus 2t. So dv over dt equals 0. Then 5t minus 2t equals 0. T equal 2.5. When t equal 2.5, substitute this one and we will get v equal 9.25. We already claimed that this is a maximum by looking at the symbol. And so that is the maximum, and we know that 2.5 lies in this interval, given interval. So we need to find when t equals 7 for part C to describe v equal 3 plus 5 7 minus 7 square, and this answer we will get 3 plus 35 minus 49, which is minus 11. So we have a negative answer. It means it is moving to the opposite direction where it was. Particle is moving in opposite direction. Question number 4. At time t equals 0, troika is at point P. It moves, or troika is at point P, and it will move to certain maximum distance and it will come back again. So the first question is, so the relationship is given distance and the time is equal 1 over 5 4t minus t square. The first one is find the maximum displacement. So we can find the maximum displacement. I know this is a quadratic equation. A is less than 0. Hence the curve has maximum. Now ds over dt, so this is going to be 1 over 5 times 4 minus 2t. If you feel this is confused, so you can multiply by this one, 4 over 5t and 1 over 5t square, and you can find ds over dt, but because 1 5 is going to be vanished when v equal to ds over dt equal to 0 to find max or mini. So 1 over 5, 4 minus 2t equal 0, 2t equal 4 and t equal 2. So when t equal 2 is equal 1 over 5 times, so we will get the maximum at max at when t equal to. So when t equal to, we find the displacement 1 over 5, 4 times, 2 times, sorry, I use this one, we have to use this one, 4 times 2 minus 2 square. So 1 over 5, this is 8 minus 4, that is 4 over 5, that is going to be 0.8 meter. Part B is the time taken to toy car to return to P. So when it is returned, the displacement is equals 0. So we'll find the time when s equals 0. So 1 over 5, 4t minus t square equals 0. So I can factorize t. Then this is 4 minus t equals 0. T equals 0 or t equals 4. So when t equals 0, the car is here, then it will go back and come back again with when t equal 4. So journey time is 4. So half of the way is 0.8 meter. So that is the maximum distance. So 1 is 0.8. Part C, total distance travel. So it will go 0.8 and come back 0.8. Total distance travel is 0.8 plus 0.8 equal 1.6 meter. Part D, the value of the t which the model is valid for. So it's going to be something like this, and this is t equal to max, and this is 0. We found out this is 4. T equal 0 or t equal 4. So model is valid when 0 greater than t equal 4. This is t and this is s. Question number 5. Um, a particle moves straight line in a velocity v and time t, and the relationship is given v equal 3t square minus 10t plus 8. 10t plus 8 and t greater than or equal to 0. Part A is find the initial velocity. So initial velocity when t equals 0. So v equals 3 times 0 minus 10, 0 plus 8. So initial velocity is 8 ms minus 1. And part B, the value of t when the body is instantaneously at rest. So for a moment it is rest. It means v equals 0 when the particle at instantaneously rest. Then 3t square minus 10t plus 8 will make equal to 0, and we have to factorize this one. So this is 3t minus O and t minus 2 equals 0. So t equal 4 over 3 or t equal to that this is instantaneously at rest. Part C, the velocity of t when the velocity is 5. So when v equal 5, so we need to find the time. So 5 equal 3t square minus 10t plus 8, then 3t square minus 10t plus 3 equal 0. So this is going to be 3t minus 1 and t minus 3 equals 0. So t equal 1/3 or t equal 3. So when we equal 5. Part D, we need to find the greatest speed of the body in the interval of 0 greater than 2 greater than 2. So we need to find the greatest speed. First of all, this is a quadratic curve and it has a minimum. So we will get an idea about the minimum. So dv over dt equal 60 minus 10t, 60 minus 10. So dv over dt equals 0. So 60 equal 10, t equal 10 over 6. That is 5 by 3. So 5 by 3 mean this is going to be 1 and 2/3 or something 1.6. This kind of curve we will have. This is the uh, one is 4 by 3 instantaneous uh, rest, and this is t equal to, and this value t value is going to be 5 by 3, and from here to here maximum speed. So we want to find, we can see that the maximum speed is here, the 8 when t equals 0. Hence maximum speed is 8 ms minus 1. Question number 6. A particle P moves on the x-axis. The particle P moves on the x-axis. The relationship with the velocity and the time is given. V equal 8t minus 2t square. So this is a quadratic equation. We can see that a value is negative, so it has a maximum. The first question is the time taken for the particle to come to an instantaneous rest. So when v become 0, so when v equals 0, 8t minus 2t square equals 0. We can divide by 2. 4t minus t square equals 0. I can factorize. 4 minus t equals 0. T equals 0 or t equal 4. Now we have the idea that this is something like this. This is v, t, this is 0, 0, and this is 4, 0. So this is the maximum, it will be somewhere here. So part B is the greatest speed of the particle during this 0 to 4. The interval is given 0 greater than t greater than 4. So during this interval, highest speed. So we can simply get two ways, either completing the square or differentiating. This one I'll go for differentiate. dv over dt equal, this is 8 minus 4t. So at a stationary point, dv over dt equals 0. That is 8 minus 4t equals 0. T equal 2. So when t equal 2, we will get the higher speed. because it can be maximum or it can be minimum, but um, we have to give a thing since a is less than 0, curve has a maximum. Hence max speed v is 8 times 2 minus 2 times 2 square. So this is 16 minus 8, which is 8 ms minus 1, that is the max. Or you have to do the complete in square. So v equal 80 minus 2t square, v equal minus 2t square minus 80. So we'll take minus 2 out, t square 40, then minus 2, t minus 2 square minus 4. So this is going to be minus 2 times t minus 2 square plus 8. So t equal to is a symmetric line, and this is 8 maximum, 0 8, sorry 2 8. Question number 7. At t equals 0, particle move on a straight line, and particle move starting from O and then come back again. The s equal 3t square minus t cube. So model is valid from during this interval. We need to find the t value. So model should be valid until it is returned to the starting point. So we'll check how many s is 0, how many times for which t that s becomes 0. Uh, let's take s equals 0, then 3t minus square t cube is 0, t cube minus 3t square equals 0 multiplied by minus. So when we take t square out, t minus 3 equals 0. So we have two options, t equals 0, that is repeated root, or t equal 3. So we know how to draw a graph from the chapter 4 on year 1. So this is going to be some graph something like this. So this is t and this is s, and so negative t, it's not, we don't consider because t has to be greater than 0, and so this is the only other point that only one occasion the point returns. So the model is valid in between this duration. So one end is t equals 0 and the other one is t equals 3. So capital T has to be equal to 3. So 0 greater than t greater than or equal to 3. Question number 8, it again a standard question. A particle P on x-axis toward the increasing direction, particle, and velocity and time relationship is given by this equation 105 3t square minus 10t plus 3. So t greater than or equal to 0. So part A, find the instantaneous rest. So A, so V equals 0 to find the instantaneous let V equal 0, then 1 over 5, 3t square minus 10t plus 3 equals 0, that is 3t square minus 10t plus 3 equals 0, that is 3t minus 1 and t minus 3 equal 0. So t equal 1 over 3 or t equal 3. So particle is at instantaneous rest when t equal 1/3 and t equal 3. Part B is we need to determine the greatest speed during this interval. So we need to get an idea about the curve. So we can say this is a quadratic curve, a greater than 0, hence curve has a minimum. Curve has a minimum as a greater than 0. So we will find when t equals 0, it's going to be 3 over 5. This is 0, 0, and v value is 3 over 5. So see 3 over 5, 1 data. We'll find the minimum point. V equal 1 over 5, 3t square minus 10t plus 3. So dv over dt is 1 over 5, 6t minus 10. So dv over dt equals 0 for minimum. Then 6t minus 10 equals 0, t equal 10 divided by 6, 5 divided by 3. When t equal 5 by 3, we will get the maximum or minimum value. So its graph is going to be something like this. We found out this value is 0, 5 by 3, 3 by 5, 0, 3 by 5, and this is here 1/3 0, and this is 3 0. So maximum value at 5 by 3. So we'll find the speed first of all. V equal 1 over 5, 3, 5 by 3 square minus 10, 5 by 3 plus 3. So V value from, so I get 16 over 15. So now we can see this is negative, but this value is greater than 1. So this is the highest one in the positive side. So this is less than 1. So in this case, actually this kind of graph I had to draw. Something like that. So this is 3 0, and this is 5 by 3, and this height is minus 16 over 15. So when you look at the magnitude, so this is the highest magnitude. Now we can see that the particle move and come up to here when t equal 1/3 instantaneous velocity 0, change the direction, and then it's move. So in the other way around, the other direction, they made the maximum of 16 over 15. So out of both direction, the maximum speed is 16 over 50. So maximum speed is 16 over 15 ms minus 1. This is velocity and this is time.